another lead code easy problem. Find pivot index. So it is given in the question, given an array of integer nums, calculate the pivot index of this array. What is the definition of pivot index? The pivot index is the index where the sum of all the number strictly to the left of the index is equal to the sum of all the number strictly to the index right. If the index is on the left edge of the array, then the left sum is 0 because there are no element to the left. This also applied to the right edge of the array. Return the leftmost pivot index. If no such index exists, return -1. So let me walk you through one example test case. Here we have given an integer array nums, and the value of the array is 1 7 3 6 5 6, and the output is 3. So 3 is the index which is acting as a pivot index here. So if you count from starting 0 1 2 3, so this is the pivot index. Why this is the pivot index? Because if you sum up all the number present in left side will be equal to sum of all the number present in the right side. So sum of this number left sum of all the number present in the left side is 11, and sum of all the number present in the right side is also 11. Let me walk you through the another example. 1 2 3 is a array, is the value in the array, and here we have no pivot index. Why? Because there is no index exist where the sum of all the element is in left and sum of all the element in right is equal. So this is very easy problem if you know the concept or one concept of array to solve this question. So the concept is known as prefix sum. So what is this concept? This concept says that if I have an array, let me copy this one only. Yeah, so if I have to find all the if you have to find sum of all the element in the array, so one way is to iterate over the loop and take a variable sum, and then iterate over all the element in the array and then add the value to the sum. So this is one approach. But if I say to say to calculate sum between this index to this index, so in that case you again have to loop start a loop from this index to up to, and the loop will continue till this index. So you see the pattern, you are calculating again and again the same sum thing, right? So one way to solve this problem would be create a prefix sum array, and this sum array will hold the data hold the sum of all the element which is available prior to it. So first element at 0th index there is no element before, so it will have the sum of itself only. Here the element array value is 7, but the one is already present in left, so here the sum prefix sum would be 8, right? Similarly here it would be 11, here it would be 17, here it would be 22, and it would be 28. So this concept is known as prefix sum. So what how we are going to solve this problem using this concept? So what we are going to calculate a prefix sum which is holding sum of all the element prior to its position, and we are going to calculate suffix sum. So suffix sum, the definition of suffix sum is to we will calculate the sum, but this sum will start from end of the array, not the beginning of the array, from the end of the array, right? And then we'll iterate over the iterate from 0 to n minus 1 index of the array, and then we'll check all the value uh, all the index where the prefix sum value matches with the suffix sum value. So let me demonstrate this with the help of this example. So prefix sum of this array and this, let me calculate one. So it is 1, it will be 8, 11, 17, 22, and this would be 28, right? Yeah. Yeah. So and what would be the suffix sum for this array? So suffix sum would be, first it would be 6, then it would be 11, then it would be 17, then it would be 20, then it would be 23, I guess. no, I guess it would be 27. Then it would be 28. So I am a bit confused about the sum. Let me calculate again. So first it would be 6, then 11, then 17, then 20, 27, 20. So yeah, that's perfect. Okay, so this is the suffix sum, this is the prefix sum. Now what we will do, we will check uh, starting from 0th index. 1 and 22 matches, no. 8 27 matches, no. 11 20 matches, no. 17 17 is matching. So what is the index of this value? So 0 1 2 3. So at third index, both prefix and suffix sum value matching, so this would be the pivotal index. So let me comment it out and let's write code now. So how we'll do this, we'll create two array. Prefix sum, initially it would be empty. Yeah, initially it would be empty. Then we'll create suffix sum. This will not be an empty array. This will have let me calculate the size of the array and store it in a variable n. Yeah, so we calculated size, then create an array having same size, calculating prefix sum. For I in range of okay, for I in range of 1 to n. Yes, and let initialize the 0th element nums of I only. Yeah, now prefix sum dot append prefix sum of I minus 1 plus nums of I. Sorry. Now we'll calculate suffix sum. So this loop will start from end of the array. So it will start from n minus 2, then it will go up till 0, and at each iteration I am decrementing the value of I. This suffix sum array would also have the default value at the last index, which is the nums of n minus 1, right? Now what we are going to do, suffix sum of I equal to suffix sum of I plus 1 plus nums of I, right? So now we have both prefix sum, suffix sum, and the third step would be iterate over the prefix and suffix sum array and find the index where both arrays value is equal and return index, right? So for I in range of n, if prefix sum of I equal to suffix sum of I, if value at same index of both the array matches, then return I. Otherwise we know that we don't have any index which can be act as a pivotal index. One edge cases could be if length yeah, if not nums, return -1. So you can write this, or otherwise or you can ignore it, but it is good to check the null value or empty array before hand, so it would be easy for you to prevent some error like index out of bound error or index error. So let me test it. Okay, so I do not have. Okay, so we can replace it with a 0. Yeah, yeah, it is successfully passed. Let me run more test cases. Or all sample test cases passes, let me submit this. Okay, so as you can see, our solution works and it is faster than 46% of the Python 3 online submission. So talking about the time complexity and space complexity, so since we are creating two array which is having like same kind of space, which is taking same kind of space, so space complexity would be order of n, big O of n, right? And time complexity would also be big O of n. Why big O of n? Since we are iterating over the array once, here we are iterating once, then again we are iterating over the array again, but it would add up to n time only. So space and time complexity both will be 1 only. Okay, thank you guys.